Welcome to Comprehensive Code YouTube channel. Today we'll be solving Leetcode 1608. Special array with x elements greater than or equal to x. Let's read the question and understand it. Okay. So let's say you are given an array nums of non-negative integers. Nums is considered special if there exists a number x such that there are exactly x numbers in nums that are greater than or equal to x. Okay, notice that x does not have to be an element in nums. Return x if array is special, otherwise return -1. Okay, it can be proven that if nums is special, the value of x is unique. Let's take this as an example. Okay, so we have 3 and 5. Okay, so what we'll do is we'll go from 1 to the length of numbers. For example, in this case 1 2 2. Okay, and then check how many numbers are greater than 1. Okay, let's check that. Is 3 greater than 1? Yes. Is 5 greater than 1? Yes. So there are two numbers greater than 1. Okay, that means this 1 is not the answer. 1, therefore 1 is not answer. Okay, similarly, if we do for 2, what happens? Is 3 greater than 2? Yes. Is 5 greater than 2? Yes. There are two numbers greater than 2. See, so it meets this criteria here. See, there are exactly x numbers in nums that are greater than or equal to x. Okay, there are exactly two numbers in nums that are greater than or equal to 2. Therefore 2 is the answer. Okay, all right, so let's think how we can solve this. One way I'm thinking of solving this is iterating from 1 to the length of the num array, and then for each number we check how many numbers are greater than or equal to the given number, and see if that count is equal to the number that we choose. If that is the case, we just return the number, otherwise we return -1. I hope that is clear. Let's write this solution first, and then we'll go to the optimal solution after this. Okay, so what I'm saying here is, so let's do n is length of the nums. Okay, nums array for I in range 1 to the length of numbers. We should go +1 in Python because this is non-inclusive. And now we check, like, if count, if I have that, count numbers greater than this number. Okay, if that is the case, if that is equal to the I, then we just return I. Okay, otherwise just return -1. Let's write this function. Okay, add and then number, let's say that. What we return here is we need to find the number, the count of the numbers that are greater than or equal to num in this nums array. One way we can use is filter in Python, or let's do a simple way first and then I can show you how we can use filter. Just to count equal to 0, and for num or number in nums. Okay, if num is greater than or equal to number is greater than or equal to num. Okay, if this number is greater than or equal to number, we just do count plus equal to 1, and then we just return the count. Okay, all right, so let's run this code. Okay, it passed the test, and let's submit this. It passed all the tests, which is good, but this is not an optimal solution. Let's talk about the time and space complexity for this. We are going from iterating from this range, which I say, like, if the size of length of the number is n, we are iterating n times, and then we are checking, at the worst case we're checking, like, for each number we are iterating here. That means, like, we are doing n times operation inside that, which means n square time complexity, which is not an optimal solution. Okay, another way I was saying here was to use a simple filter, so we can just do return filter. Okay, we are just using filter lambda x, and this should be greater than or equal to num, right, for all the nums that we have. Okay, and we just return the list, and then the size of that list, which is the length of that list, right? We can do that as well. If we run that, I think that should run as well. Okay, but this is, we have to find all the numbers using filters. That's why this is, and converting to that list, that's why this is a little bit more time consuming than the previous method. Okay, which is this one. All right, let's talk about another solution, how we can do this. Okay, so let's see the same thing, 3 and 5. Okay, what we're gonna do here is basically see, we can use index. So index is here, and then the count or frequency. So basically 0 and then 1. Okay, so 1 2, we will make an array of size n plus 1, which will basically store the frequency or number of occurrences here. And what that count will be is the minimum of, so we'll do, that count will maintain the minimum of n and then num, and we iterate through all these numbers. Okay, and let's see, if we iterate through all this number, first one is 3, and then the n is 2 here, right? So what is the minimum of 3 and 2? It is 2, right? So we just increase the count in second index 1. Okay, and then for 5, what is the minimum of 5? And the number is 5, and then the size is 2. Okay, what is the minimum of 5 and 2? That is 2. We just add that as 2, and we initialize this as 0 at the beginning. Okay, and then in the next pass, what we do is we just iterate from the last, okay, from the last till this point. Okay, and then what we do is, for each of this number we can add this, because for this number, for this one, we can just add 1. Basically, like, there are 3 numbers that is greater than or equal to at this index, right? I hope that makes sense. And with that, like, let's write the code for this one. Okay, so what we're doing here is, let's just delete this, and what we said is we'll maintain a counter. Okay, which will be basically 0 times n plus 1, right? As I said, we'll maintain that counter, okay? And then for each numbers, for num in numbers, we will do counter and then the minimum of n and then num, okay? That should plus equal to 1, okay? We just do that. We maintain the frequency now, and we just do num greater than or eq equal to 0, okay? We just initialize that to 0, num greater than or equal to 0, okay? Just initialize that, and we just do for I in range, what we said is we'll go from the last and then up to 0th point and decrement it by -1, okay? And we just do that plus equal to the frequency or counter that we have in I, right? Now if that is equal to I, that means we just return I, okay? And then if that is not the case, we just return -1, okay? So basically, let's recap what we did. We just maintained a counter like this, okay? And then what we did is we did counter of minimum of n to number plus equal to 1. That means we define a counter of array of length n plus 1, and then we just find the minimum and add the counter, okay? And then what we did is we just go from the last index and add the counter I to that number greater than or equal to at that point, and then we just check like if that is equal to the I, that is the case, we just return I, otherwise we return a -1. Let's run this code, see if it's, yeah, it passed all these 3 test cases, and let's run this, submit this. As you can see, this is pretty efficient. And let's talk about the space and time complexity for this solution. So for this solution, space complexity or time complexity is, we're just iterating through all these numbers here and then here. So this time complexity is order of n, and then the space complexity for this problem is order of 1 because of order of n, because we are using this counter to store the counter or frequency of these numbers, okay? So that is the time and space complexity, and with that we come to the end of this problem. If you like the solution and if it helped you, just hit like and subscribe, hit subscribe button, hit like button. It will help me grow a lot. I want to grow this channel, and I'll bring a lot of these solutions in the future. Thank you for watching this video and hope to meet you soon.